Can start now.
All right, thanks, Lynn. And I think we are live. Thank you, everyone, for joining the Archway workshop on DoraHacks .io. Today, we are introducing the Archway Hunt-A-Thon. My name is Jeff, and I'm super excited to be here today with Adrian, who will be introducing and giving us a little workshop presentation on Archway and Phi Labs as well. Before we dive deeper into the workshop, I kind of want to give a quick introduction to the hackathon, what it's about, and what our expectations are going forward. The hackathon is a unique opportunity for Cosmos native layer one blockchains developers to enter the ecosystem to foster diverse and sustainable application and empower and more developers to build on the network. The current Hunt-A-Thon is going on. There's about 20 days left, ending around June 7th with a $100,000 prize pool. There's already some solid submissions that have come through. If you haven't joined the hackathon yet, there's still time, and we really encourage you to do so. It's an exciting opportunity to participate in the Archway ecosystem and, to build on the ecosystem as well. So before we jump in, I kind of want to give the stage to Adrian to introduce himself, to talk a little bit more about who he is and what the workshop's going to be and what he's looking forward to the hackathon. So without further ado, Adrian, the stage is yours.
Thanks, Jeff. Okay. So hi, everyone. So my name is Adrian Thompson, and I'm one of the developer relations engineers at Phi Labs. And Phi Labs is one of the core contributors to the Archway protocol. So today's presentation or workshop will be focused on giving an introduction to NFTs on Archway. And NFTs is based on the CW721 standard. So this is mainly focused or targeted to developers new to the space. You might have worked on NFTs on other platforms, or you're coming from the Web2 space, and you don't really know much about what NFTs are, how to go about building out smart contract to utilize them. So this will be a workshop like going through the basics and then covering various different variations of the core CW721 NFT standard. So, yeah. So should I go and present now, Jeff?
Yeah, that'd be great. If you can get us started to present, we're ready for you.
Okay, let me share my screen quickly. I think I can share my entire screen.
No worries. And if anyone has any questions, feel free to ask in chat. We'll take a look at them and answer them as we go. We'd love to have an open discussion and just continue having a conversation. So feel free to ask any questions. But I think, Adrian, you're ready and looking forward to this workshop presentation. Thank you so much.
Let me know if you're seeing my presentation.
Yeah, I see your presentation live now. I think everything's good to go.
Okay, great. All right, so a quick overview of the agenda. So I'll be giving a quick overview of NFTs, dive into the CW721 base contract, which is a basic implementation of the CW721 specification. Then we look at NFTs with on-chain metadata. If you're coming from the Ethereum space, NFTs don't store their metadata on-chain. They usually store it via IPFS or some other solution. But Archway allows, or Cosmos in general allows for a larger amount of data storage within your contract data store. So it allows for that. So there are use cases where on-chain metadata storage is very, very useful, as your contracts will have instant access to the data. But then still, there are instances where it makes a lot more sense to use IPFS or other off-chain storage solutions. And then we'll jump into soulbound NFTs that you won't be able to change the owner. And then also updateable NFTs, which is somewhat of a new spec. Yeah, I think there might be solutions on other chains, but I think this, compared to what I've seen, this might be new for Cosmosm space. And then finally, we look at fractionalized NFTs, and this is definitely something new across the space. I think there might have been like 1 or 2 implementations, but not many. But it's something that is very interesting, and if you want to create a unique solution, I think this could be something that you could look into, and then we can tap into other variants of the NFT specification. All right, let's jump into the basics. So NFTs stands for non-fungible tokens. Most should be very familiar with fungible tokens like or CW20 tokens or ERC20 tokens or general tokens that you see on other chains. And it's fungible because all those tokens are identical. Essentially, they are the same tokens, and so because they're the same, they represent the same value and they're interchangeable. But NFTs, non-fungible tokens, on the other hand, are unique assets, and because they're unique, they're very distinct because they have unique properties, and because of this, they have different use cases compared to what we're used to with fungible tokens. So you'll see a lot of digital art ownership, music, and in-game assets and stuff like that being used as NFTs. So yeah, another characteristic within the general scope is that an NFT must have an owner. For general tokens, I think this is based on the general spec. So for example, when you're creating an NFT on Cosmosm, you have to assign an owner immediately. It usually allows for storing additional metadata. I've said this before. There's some general metadata that you'll store based on the general specification from ERC721, like the name, maybe a symbol or token URI. But the additional metadata would maybe be a part of the token URI, where you can link and add a lot more information that will be used to describe the NFT. And in general, NFTs usually allows for users to transfer from one account to another or allow a contract or some other account to have some control over the NFT so they can execute a transfer as well. So that's the general makeup of NFTs. And the Ethereum community created the first NFT specification, and what we have here on Archway is based on that same specification. So the ERC721 specification paved the way for NFTs, and also for the general fungible tokens within the ERC20. We have the CW20 here on Archway, but we took the CW721 specification and made some modifications to make it a little better. But the base structure of the NFTs are quite similar. So on Ethereum, you can transfer and set the approvals, and we do a similar thing, but the function structure is a bit different. So you can transfer, send NFTs to a contract, approve or revoke permissions. That's the general actions that you can execute. And the general metadata, as I said before, you have the name, the symbol, and the token URI is like a resource identifier, is like a link to additional information that will be tied into the NFT. And this is a general structure, basic structure of how that schema would look for the base case. for OpenSea, the OpenSea setup, they've added a lot more to this, which we also utilize. But from the base case, this is what it is: name, description, and maybe an image. So let's jump into the base NFT contract based on that specification that's on the it's available on Archway. So this CW721 base contract is a basic implementation of the specification. Usually, you can definitely deploy and instantiate this contract as is, but most use cases would require like extending the feature set available within the base contract. So you'll import and extend, add on the unique features that you'd want your NFT to mimic. And this particular implementation, so the base case doesn't have anything to do, doesn't state anything in relation to minting, but the CW721 base contract allows for minting new NFTs in the collection. And a minter address, which has to be set on instantiation, is required for minting new NFTs. So this is the contract, this is the address that, this is the only address that can do any form of minting. This is usually set as a smart contract address. So within your smart contract, when an end user executes an entry point, that entry point will then use the minter address to create a new NFT within the collection. So let's quickly look at this base contract. So within the CosmWasm organization on GitHub, there's a CW NFTs repo, which houses a number of sample contracts. And this is the one we're looking at right now, the CW721 basic, CW721-base. And if we go in the source, let's look at the state file first. We'll see the current makeup in terms of the data store, what this contract actually stores. And the contract itself stores this contract information. And it's really just, the contract info. Oh, this is the response. So it actually links to the token info. And the token info would show the owner of the NFT, any approvals, the actual token URI that's linked, and it's optional, so it doesn't have to be set, and any extension. And the extension allows for, this is where the on-chain metadata contract will use or create a struct and store a specific data set within the data store of the NFT. So then it is tied to that particular NFT. And this will be stored on-chain. So this is how we allow for on-chain metadata storage. So a token count, operators, these are, if you see here, this is a tuple with an address and an address. And the first address, I think, is the address of the user or the user account, and then the address of the operator, the person you're given permission to execute actions on their behalf, on the user's account behalf, and then if there's an expiration on that. And then the actual tokens, which is the NFTs, and as showed before, that will have token info, and they create an index to make it easy to be searchable. Very basic stuff that you would require for querying the data set, like the contract info, which will return the basic token info, or the contract details, like the owner, the mint address, the name and symbol, or the symbol of the token collection, among other information. Tokens returns the number of NFTs within the collection, and NFT info return the info actual data on the particular NFT. Owner of shows the owner of the actual NFT, and operator, as I showed, person who would have permission to execute actions on behalf of a user account. If we go into the messages, look and see that there's a general instantiation message that's required, and you need to submit a name for the NFT collection, a symbol for the NFT connection, and even though this is optional, I think it's enforced that it's required within this particular contract. Withdrawal address is any fees received by any fees earned by the contract would go to this particular address, and this is not really used as much. I've seen other variants of this contract removing this withdrawal address. And these are the various actions that you can execute. You can transfer an NFT, which is transferring from one account to another. Sending an NFT request is sending from an account or a contract to another contract. Approval is executing an approval for an operator and then revoking the permission for another operator. And seeing this approving all operator give an operator access to every single token, even future tokens that you might have later on, or removing all. And then this action is really just to mint. And a unique component here is that you are also able to burn an NFT, and this will just destroy the NFT. So once you burn it, no one has access to it again. And then the NFT count, the total number of NFTs will be reduced by 1. And the extension, this will allow for adding that additional metadata that you can store on chain. And then the basic implementation of each of those actions will be stored in this particular execute file. And you see the entry point here for execute, and then all the various actions will then you see the actual body of code that is used to execute those actions. So this is a general setup of the basic implementation of the CW721 NFT on Archway. All right. So let's look at the on-chain metadata contract. So this extends the CW721 base contract that we just saw, but it allows for storing any data on-chain using the generic extension that I showed earlier. So you can create a struct and add that extension to that optional field, and then the contract will then start to allow for saving that metadata and to store it on-chain. So one good thing about having your metadata on-chain as opposed to having it on IPFS is that contracts can now interact with that data and do whatever they require. If you're going to be interacting with IPFS, you'd have to use maybe an Oracle or something else to pull in that data to the chain, because that's a separate chain, and that the IPFS is it a chain? The structure of IPFS differs from what we have on Archway, so it doesn't use IBC or anything like that. So you definitely have to use an Oracle of sorts to get that data into the contract to utilize it as you see fit. So having the metadata on chain just allows for easy contract interaction. One good thing with Archway is that our contracts can store a lot more data than you have access to storing on other chains, especially Ethereum. And on Ethereum, it's a whole lot more expensive to add data on chain. which is another reason why they don't allow for that. But it's a lot cheaper to do it on Archway. So let's jump in and create a basic project, because our Archway Developer CLI, which is a tool that we recommend developers utilize for creating and managing and interacting with their contracts on chain. That tool helps you to create a project quickly, and there are a few templates that are available, and one of those templates is the CW721 on-chain metadata. So let's quickly go through and see how we go about creating such a contract. So Archway, new, let's call this project 1. So we just need to select the chain. I'm using testnet. Choose a name for the contract. Let's call it project 1. And then we need to select a template. We can select here CW721 with on-chain metadata. And this will pull down everything from the respective repository and get everything organized in a project. And the cool thing with the current implementation of our Archway Developer CLI is that it uses the workspace optimizer. So you can have any number of contracts in a project and have those contracts integrated with each other. You can embed or extend. And when you're compiling or building the WASM, it's just, you do everything with one command and everything goes through very easily. So it's like a one-stop shop for like getting everything done within the Archway ecosystem for developers. So let's see. So this is here, project 1. Let's bring up the code editor. All right, and this is the structure of that particular project. What we're concerned with right now is this contracts folder. We'll see our project here. If you create another project or there's another command to add another contract, you'll see all your contracts under this contract folder. So this particular contract, if we look at the cargo file, we'll see that it has a dependency, the CW721 base crate, and it's using it as a library, or it's enabling the library features. I think we should go back to see how the library. So what that means is that all these entry points where the feature library is enabled, you will have access to within your contract and can execute. So you can execute instantiate, all execute the queries and migrate actions. And you can make modifications to all of these functions as well. And if we look at the source, we'll see that there's literally just one file, this lib.rs file. And what this does, it simply creates the data structure that will be used for the extension that will pass into the contract. So this is the metadata struct that will be used as the on-chain metadata extension, and it simply adds these variables or fields. Image data, external URL, description, name, attributes, and attributes is a vector of traits, which is this. So this is just an example of what you can do. You have full control as to how you want to design this struct. And all of this will be available when you're creating their NFTs. So when you create an NFT, if you want to add additional metadata on chain, then you're able to set all these values. Once you decide to set it, though, you need to set, if a particular field is not required, you need to, because the string, you set the optional, set as an optional value. But yeah, this is the structure. You create this metadata, set it as the extension, which is optional. And then when you're instantiating this new contract, you add it as the extension. And if not, it will be set, it will not be set. And this is the structure, as we've seen before, where we have the contract info, count, operators, and tokens. And because we now have this extension, it will be used here. Extension, whatever struct or whatever you've passed in as the extension here, and in this case it's metadata, it will be used as the value for this field. So this is the token info field, owner, approval, the token URI, and the optional extension. And in this case, that extension will mimic this metadata field. And that's it for this particular on-chain metadata structure, because it has access, this contract has access to all the entry points, whether it's on the execute, the migrate, or the query entry points, and even instantiate entry points from the base contract. So you don't need to redo any of that. You can simply use that. If you would want to override it, you would then reinstantiate here or recreate those entry points here. But if you look here, essentially all the entry points, the instantiate entry point there, it's picking up all the instantiate entry points, or the instantiate entry points from the core base contract, and the same for the execute entry points. Here, all these entry points that you have access to within your contract, and then you have access to the queries as well, all the query entry points as well. All right, so that was very simple and it shows you just how extendable these contracts are, and how the specification is designed to just make it extendable. So when you want to make necessary modifications, instead of rewriting everything from scratch, you can simply extend a contract and add your unique feature sets. All right, so let's jump into soulbound NFTs. So what are soulbound NFTs? These are NFTs that are restricted to one address. So for example, if after creating an NFT, you have to assign an owner. Once that owner is assigned, there's no way for then transferring ownership to another account or address. So it is tied to that specific address that was assigned to it at inception. And there are a number of use cases for this, a few being like digital identity, I think would be a common one. So if you have a passport and you want to tie a passport to a particular person, you can't change ownership of your passport or your visa or your degree or your medical history. So anything that would stick to an individual for the life of that individual, soulbound NFTs could be a very useful way of representing that asset or entity. Yeah, and when you check, when we look at the implementation, you'll see that basically it's a copy of the base NFT contract, and the transfer functions are just removed. So that's, you simply don't have the entry points to execute a transfer, and that's really what's needed. So let's quickly look through the soulbound NFT, and this was created by developer Drew, who is also the creator of Archway. He's a part of the File Labs team. So yeah, if we look at this execute file and look at the various execute entry points, you'll see you still have the mint, the approve, the revoke, and our burn extension, but there's the two transfer functions are removed. And then you can go through the body of. Nothing else has really changed that much. It's really just removing those functions. So preventing the transfer of NFT assets. And that's really it. We have a learning platform called Area 52, and you can also go through the various exercises on that platform, and the core NFT stuff is based on soulbound NFTs. So you'll get a better understanding of how the contract works and how you can utilize it for various use cases if you decide to go through the learning platform. So it's a very useful platform, and yeah, it's the NFT courses are based on soulbound NFTs. All right, another type of NFTs that I think is very useful, and I'm even using this in a particular project of mine, are updateable NFTs. And by default, NFTs don't allow you to update the metadata. Once you create an NFT, that's usually it. If you have the NFT token URI set where you have external metadata stored on IPFS, for example, you can still update the contents within that. Or is that possible? I think it is. You can update the contents within, or maybe not. But if not, there's no way to update the NFT, the contents or the data or metadata within an NFT. So there are various use cases that you might require something like that. So if you're building a game and an asset might move from one status to another, and at each status or level, they might need to operate differently or have a different makeup and stuff like that. You would need to be able to update the metadata. So this does come in handy for a number of use cases. That's just one example. So yeah, updatable NFTs really just allows for allowing for evolving the metadata. Let's look at the actual contract. And this was also created by Drew. It's a part of the Archway network organization. So this repo, CW721 updateable. Let's look at and there's just mainly one major change within this. So this is the major entry point addition or message that you can add. You'll see a new message here, update metadata. Once you jump through the execute entry point and submit the update metadata message. Let's look at this quickly. You'll see that all that is required is that the only person or account that can execute an update is the account that is actually the actual minter for the NFT. So as I said initially, with the base contract, you have to set a minter address, and the minter address is the only address or account that can mint new NFTs. So in this particular use case, and most use cases, the minter would be the contract that owns the contract that the NFT contract. So in order to update the metadata for any NFT created within a collection, it can only be executed by the minter. But there is also another requirement in that the minter must also, the user that owns the NFT must also give an approval for the minter to execute or permission to execute on their behalf. And once those two conditions are met, the minter address is the one executing the update, and the minter has an approval from the owner of the token, then the update request can be executed. So what would generally happen on the front end is that a user would want to execute an update transaction. They will click that button to execute. It will go to the respective entry point. That entry point will call this update metadata, and then but the update metadata call would be done by the minter, because within the contract is now doing the call, and the contract is the minter. And because the contract is executing the call and the contract already has an approval from the owner, then this update request should go through. So that there are just two requirements there. Only the minter address can update the metadata, and there needs to be an approval from the owner of the NFT. And that's it for really the updatable NFTs. And the updatable and soulbound NFTs are available as crates, so you can pull them into your contract and utilize them as you see fit. So no need to go about trying to recode all of that. A new type of NFT, which I've been hearing a lot more of it within the last year or so, are fractionalized NFTs. And these NFTs allow somewhat for having smaller units of the NFT shared between different users. So by design, an NFT is one asset that's owned by one user. But if you've purchased NFTs before, you've seen where cases where NFTs, a particular NFT could cost like $1 million in value, and then for those particular NFTs, it would be difficult for the layman or the smaller guy to take part in that sale. So the idea behind fractionalized NFTs is to break up the NFTs a bit and then allow persons to be able to buy smaller chunks at an affordable price. The thing is, NFTs by design cannot be broken up. And so to get around this, I've seen a few solutions, but essentially everything comes down to breaking it up into fungible tokens. So you have an NFT that is locked, for example, in a contract, and that NFT then is represented as CW20 tokens or an ERC20 tokens or a number of ERC20 tokens. So if you split up that NFT in 1,000 parts, then you'll have 1,000 CW20 tokens representing that particular NFT, and then users can now buy each or one of those 1,000 representation of or small representation of the NFTs or a small portion of the NFT. And that's really the idea behind fractionalized NFTs. There is one solution that I found in particular that seems useful. Is this CW721? I've not really gone deep into the use case or how it's implemented, but I think definitely, especially for the Hackathon and the NFT track, if you would want to build out a unique solution, having or utilizing this might be helpful or useful. So this is definitely a cool idea. I think if it's implemented correctly, it can be very useful within the wider NFT space. And then having it within like the NFT marketplace would also be useful as well. So most NFT marketplaces, the only thing that you have there in terms of purchasing is NFTs. But within this particular use case, you'll have these CW20 tokens that are smaller units of the NFT. But yeah, definitely a good idea to look into if you want to take on the NFT track. And then there are some other variants, popular variants of NFTs, especially within that CW NFTs group of contracts. So you have the royalties. This just allows you to add for example, if the NFT collection owner, this allows them to add a royalty, like for every time NFT is sold. Maybe they could, so within the marketplace, when an NFT is sold, they could add a royalty percentage or a static fee that would be attached to whatever price is set within the marketplace. The collection owner would earn that. So this particular contract gives a basic implementation of how you could do that. Expiration. This is another unique one as well. So if you would want to have NFTs that after a particular time period, days, seconds, minutes have passed, you'd want the NFT to be burnt or destroyed or to be disabled or remove certain features or whatever. This implementation gives you a basic idea of how you could do that. So for this particular implementation, after a certain set amount of days, the NFT will expire. I think it will get burnt, destroyed. Some use cases of this are stated here, like access cards, SLAs, cloud services. So anything that has a time period associated with it, this could be a very useful implementation. And then fixed price, if you want to allow for NFTs to be sold within the marketplace, you could restrict the price to one fixed price, as opposed to like allowing the owners to set their own price. You set one fixed price. So this just gives a basic example of how you do that. Then you could extend it to allowing each users to set in their own price, and then having, whether it be a CW20 token or I think, this uses a CW20 token contract where payments are made. And so these are just examples that I would hope developers can build upon, utilize, and build out even more practical solutions within the space, especially when it comes to our NFT track. Let's go to the DoraHacks track. So as we've shown, these are some ideas of what we're thinking users could actually, or solutions that users can, developers can build, but it's not restricted to any of these. But just giving you an idea of the various NFT solutions out there already, you should be able to look at these and get some ideas of what I could build out just by implementing or starting off with any of these solutions. Soulbound. Soulbound solution, as I've said before, you definitely, if you're new to the space and you'd want to get a better understanding of how this solution work and how we could implement it in your contracts, I recommend you going to Area 50 to signing up and go through the various courses. Starting with Cosmosm, I think this second course is where you will see the soulbound NFT be utilized. So there are two active courses right now on the platform, and I encourage you to go through and get a bit understanding of NFTs on the Archway, and building out very useful projects that are based on NFTs. So I hope that was helpful. That's the end of my presentation. If there are any questions, please, you can share them in the chat. Jeff?
Adrian, really appreciate, the technical deep dive of the workshop and, helping the developers understand the code base a little bit more and, giving a good idea on what to build out. I really hope it helps the developers and viewers get a better understanding of the contract code and the operation on how to deploy NFTs, the risks, the burning mechanics that we kind of went through today. Um, I just want everyone to, I just want to remind everyone in the audience and people that are going to be watching this later on for the recorded session. All the links will be, presented on the live stream. So, take some time to go back, try to copy the links, and also be in the comment section so you could find it there as well. So just a few questions that, I would like to ask you, Adrian, if that's okay, before we conclude this session. For one thing, I know you quickly went over, some cool ideas that were in the NFT track that developers can implement and submit to the hackathon. In your opinion, personally, what do you think would be a cool project that developers can use and implement and leverage from this workshop to build out for this hackathon?
Yeah, so along with, so I know that ArchID has a domain name solution already, and it can also be used as an identity verification solution as well. But I think, like, if you don't want to take on that particular track where you're building on top of ArchID, you could build out your own soulbound type identity verification solution using NFTs. Another good idea would be having like a game where you have various assets that persons can purchase, groom over a period of time. Grooming could be like feeding, cleaning up, or whatever you decide. And these assets could all be created as NFTs. Even like purchasing various assets to feed the actual asset, which could be like a dog. The assets that you purchased to feed them would be NFTs as well. So you could have a game where every single asset within the game is recorded as an NFT. For example, if a dog eats something, you then burn that food item that was purchased and used. So then you see the burning mechanism coming into play there. So stuff like that, I think, would be useful and creative. But yeah, it's not limited to what I can think of or what we've posted there. But yeah, I think all these new developers coming up and they've been exposed to a lot of things, they will have a bit way more unique and creative ideas.
Yeah, of course. Well, I appreciate your insight. And I mean, everyone in the audience, you guys heard it here first. Some great ideas that Adrian pitched to us today. You could take it for your own ideas or, use it as an influence for your projects that are coming up. Yeah, before we continue with other questions, Adrian, I kind of wanted to understand a little bit about more what Phi Labs does, your connections with Archway, and just kind of the relationship. If you want to kind of give a little quick intro about Phi Labs a little bit more, and how you guys are, the relationship between Archway and to this hackathon. Yeah.
Yeah, so Fire Labs operates as the core contributor to Archway. Essentially, well, Fire Labs created Archway initially, but the Archway protocol is really managed operated by the Archway Foundation. But Fire Labs is like the core contributor in terms of the tech behind the Archway protocol. So we are the main force behind like adding new features. We just released an upgrade that has 4 new modules that we are hoping developers will utilize within this hackathon. And yeah, so our mandate really is to be one of the uh, the developing team behind the creation or maintaining the the protocol. Or yeah, so the foundation's role really is to help grow the community, and the community being the general user, the validators, relayers, and other stakeholders. So it could be other core contributors and stuff. But currently, Firelab is the main and only core contributor. But we're trying to see how best we can get other contributors um, within the ecosystem. So, but yeah, I think we're doing a good job so far in terms of pushing out creative products, ideas. We had Drop Camp just a few weeks ago, and yeah, we're building a lot of stuff internally, and we just want to provide the best tools for developers to build the best dApps on top of Archer, really.
Yeah, that's awesome. Thank you for clarifying that and establishing what you guys are doing with Archways. It's pretty cool what's happening. Yeah, so for developers, what Adrian kind of highlighted is that there's tools that are kind of building for the Archway ecosystem. So if you have any questions, feel free to reach out to DoraHacks directly or to the Archway Foundation or to Phi Labs. You can find all the social media links below. Also on the DoraHacks website, you can join our Discord, our Telegram, and feel free to ask us any questions for the building process and any developer questions that you guys might stumble upon when submitting your hackathon or building out your project. We're more than happy to support you in any way possible, and I'm pretty sure Archer would love, and the Phi Labs as well would love to have you guys on board, asking questions and just using the tools that are available to you guys. So feel free to reach out to our social media at any time if you have any further questions. Yeah, with that, Adrian, if you have any, closing remarks, statements that you may have for the developers for the hackathon that is ongoing, please feel free to share them now.
Yeah, so I just want to encourage developers like at any level to really try to contribute and take part in the hackathon. If you're like a new developer to the space, it's not a problem. We have our Discord server that you can join, ask any questions. I'll try to help. Other developers will be there to try to help. If you're not a developer yourself but also want to contribute or take part, you can join the Discord as well and pitch your ideas to various developers and see if anybody will be willing to join your team. So yeah, I was asked yesterday if there's like a limited number of persons that can be on a team. There's no limit. Uh, it doesn't matter. We just want product submissions. We just want to have good ideas being shared. Um, and teams that will be able to like deliver. So like yeah, and we're really looking for a large number of submissions this time around. The last hackathon we had was before mainnet launched last July. And even though it was a success, I think we were hoping for a lot more submissions. So we're hoping to see a lot more submissions this time around. And we have a larger number of tracks this time around. So especially with the mobile track, I'm hoping to see some mobile submissions, because generally within the crypto space, we don't see a lot of mobile dApps being created. So yeah, we're hoping to see a lot more submissions there. And yeah, I'll start sharing a lot of these workshops throughout the various channels that we have. So we have a number of channels on Telegram, Discord, and also on Twitter. So just to get developers from all different areas, like I get them the necessary information they need, because I think there are so many. Because the last time I checked, there are about 26,000 devs within the crypto space. That's a very small amount. So we don't have a lot of devs within the space. So I think a lot of devs are still within the Web2 space, and we're trying to get those devs over to Web3. So a lot of these workshops are not highly technical. I think they're easy to grasp. I'm going to start sharing them and getting them out there to see if we can get more developers from Web2 or other ecosystems submitting for this particular hackathon.
Awesome. Yeah. Thank you, Adrian. Really appreciate that. And, even if you are an experienced or even an experienced developer, you want the end goal is to have you guys come over to the Web3 space, build actively in the Archway ecosystem, and hopefully, have these dApps built out and be important ecosystem projects in the Archway ecosystem. And, going forward, they become integral projects that really help support the ecosystem. But yeah, if you're an inexperienced developer and you have any questions, feel free to reach out in their Discord. Feel free to reach out to us at any time. We can help you get connected. We can also share the resources as well. If you're an experienced developer and if you're looking for a team as well, either of our Discords, we can help match you with other teammates. And like Adrian said, we're just hoping for a lot of submissions. But the most important thing is that you do put effort into these submissions. Even if you're experienced and don't feel like your, structural development isn't top tier. As long as you put the effort in, and we can see that you put the effort in, I think that's the most important to the judges and the people overseeing this. So yeah, Adrian, if that's the conclusion of our video, I think, if you don't have anything else to say, I think we can start heading off.
That's it from me. Thanks a lot, Jeff, for having me.
Awesome. Thank you so much, Adrian, for coming on today and, taking the time to, talk a little bit and, give a demonstration in the workshop. We really appreciate it.
Thank you.
Awesome. Thank you so much. And Lynn, I think we're ready to go. Hope everyone in the audience has a great day, and thank you so much for taking the time. We really appreciate it.